This is not a normal boat, and it is not a normal aircraft. The REGENT Viceroy Seaglider is a wing-in-ground effect vehicle that floats on its hull, rises onto hydrofoils, and then flies within one wingspan of the water's surface. And this is not concept art. The full-scale prototype stretches 55 feet long with a 65-foot wingspan, and the United States Marines just put millions of dollars behind it. 3 distinct operating modes define the Viceroy's approach to littoral movement. The first is hull-borne travel. At low speeds, the craft sits in the water like a conventional boat, supported by a catamaran-style hull. This phase is all about stability. Buoyancy checks, electrical system integration, and basic navigation are validated here. Hull mode operates up to around 30 knots, using the same electric motors that power later flight, but driving a central water jet for propulsion. Once the Viceroy accelerates, retractable hydrofoils deploy beneath the hull. These foils lift the craft clear of the waves, dramatically reducing drag and allowing speeds up to 50 knots. Hydrofoil mode is not just a speed boost. It smooths out rough water, eases the transition to flight, and protects the hull from wave impacts. This is a key engineering step. Older ground effect vehicles struggled to get airborne in choppy seas, but the Viceroy's foils handled the heavy lifting. The final phase is ground effect flight. At around 50 knots, the wings generate enough lift for the vehicle to rise off the foils and cruise just a few feet above the water, never exceeding one wingspan in altitude. Here, the Viceroy exploits a cushion of high-pressure air between the wing and the sea surface, cutting aerodynamic drag nearly in half compared to a normal aircraft. This ground effect is the secret to its advertised cruise speed of 160 knots and to its extended range, all while staying low enough to avoid most radar detection. Throughout all 3 modes, a fly-by-wire system coordinates hull, foil, and wing controls, adapting to changing sea states in real time. The result is a craft that is not quite a boat and is not quite a plane, delivering speed and flexibility that neither category can match on its own. On October 18, 2023, the Marine Corps Warfighting Lab made its commitment clear by awarding REGENT a $4.75 million contract. This was not just a research grant for concept art or digital renderings. The agreement funded the construction and testing of a full-scale operational prototype, the kind of step that moves a technology from whiteboard to water. Official records show the contract under the Department of the Navy, with the funding line listed as Advanced Maritime WIG Technologies in the Department of Defense budget for fiscal year 2024. The contract set out 12 specific deliverables, including quarter-scale model test, integration of the electric propulsion system, and the start of full-scale sea trials. By March 26, 2025, REGENT had met every milestone. That triggered a second phase, a new contract estimated at $10 million but with a ceiling of $15 million, signed the same day. This phase expanded the scope from basic hull and foil testing to include demonstration of real-world missions, medevac, ISR, and rapid resupply, plus funding for the build-out of REGENT's Rhode Island production facility. The Marine Corps did not just write a check and walk away. Contracting officials from the Warfighting Lab worked alongside REGENT engineers, overseeing test data and verifying each step before the next payment was released. Congressional budget documents confirm the $15 million total allocation, split between research and prototype manufacturing through fiscal year 2026. These numbers and dates are public, not rumor, and they are evidence that the Viceroy program is being treated as a serious candidate for future littoral operations, not a speculative side project. In a defense environment where dollars are scarce and competition is fierce, this level of funding and oversight signals that the Marine Corps expects more than a technology demo. they want proof of operational value. Expeditionary Marines face a stubborn problem in the Pacific and around the world: how to move people and supplies quickly across a maze of islands, shallow waters, and contested coastlines. Traditional landing craft and amphibious ships crawl ashung at 30 knots, often taking hours to cover gaps between forward bases. Helicopters and tilt rotors can fly over these obstacles, but they burn fuel fast, make noise that carries for miles, and stand out to radar and infrared sensors. Every time a helicopter lifts off, it risks detection and draws attention from enemy defenses. The Viceroy aims to break this deadlock. Its ground effect cruise speed, 160 knots or about 180 miles per hour, puts it in the same league as a Marine Corps MV-22 Osprey, but without needing a runway or flight deck. Because it skims just a few feet above the sea, the Viceroy stays below the radar horizon for most shore-based sensors. That low profile means it can approach or depart from island outposts with less warning, slipping between radar sweeps and avoiding the high altitude exposure of helicopters. For Marines tasked with moving a 3,500-pound payload, enough for a full rifle squad, a medevac stretcher team, or critical supplies, the difference is measured in hours saved and lives protected. In an island chain environment where speed and surprise can decide the outcome, the Viceroy's promise is simple: move faster than boats, stay lower than helicopters, and operate from any patch of water wide enough for takeoff. The Marine Corps' investment isn't about chasing novelty, it's about closing a real gap in littoral logistics, where every minute and every mile count. Lift comes easier when a wing flies close to the surface. This is the essence of ground effect. As the Viceroy's 65-foot wingspan skims just above the water, a cushion of high-pressure air builds beneath the wing, cutting drag almost in half compared to normal flight. Less drag means less energy wasted, so speed and range both climb. For a vehicle measuring 55 feet long, about the size of a city bus, the numbers begin to make sense. In ground effect, the Viceroy can cruise at 160 knots using electric motors that would otherwise struggle to push a boat or plane of this scale so fast. The science is straightforward. The closer the wing is to the water, never higher than its own span, the stronger the effect. The one wingspan rule keeps the craft low, fast, and efficient. Instead of fighting thick air and wave drag separately, the Seaglider rides a sweet spot where aerodynamic lift and hydrodynamic smoothing work together. That's how a 3,500-pound payload and a dozen passengers can move at aircraft speeds without burning through jet fuel or needing a runway. None of this is just theory. The Viceroy's performance claims, from its low drag to its ability to stay in ground effect, are rooted in physics that has been tested since the Cold War. What sets this craft apart is how it blends proven ground effect lift with modern electric propulsion, and crucially, the ability to launch from hydrofoils. Yes. The next step is understanding how those hydrofoils make ground effect flight possible in real-world conditions. On June 24, 2025, REGENT's engineering team gathered for a defining test. It was the first crewed transition to hydrofoil mode. As the Viceroy accelerated past 40 knots, the retractable foils deployed beneath the hull and lifted the 55-foot craft clear of the waves. This wasn't just a speed run. It was proof that the hydrofoil system could deliver stable, sustained flight above the water at nearly 50 knots, even with a full crew aboard. The hydrofoils are what set the Viceroy apart from any acranoplan or fast ferry. By reducing drag and smoothing out choppy seas, they enable the seamless shift to ground effect flight. Magic All's marine-rated electric motors powered the entire sequence, showing that distributed electric propulsion can handle the demands of foil-borne operation. For the Marines, this milestone means the Viceroy isn't just a paper concept, it's a working platform, demonstrating the kind of real-world performance that could change littoral operations. A 3,500-pound payload is more than a statistic. It is the difference between theory and practical use for marine logisticians and medics. That single figure covers a full rifle squad with gear, or a medevac team with a stretcher medical equipment and an attending corpsman. In a 12-passenger cabin, the Viceroy can move people or supplies in one run, matching the needs of forward island bases, where every seat and every pound counts. For rapid resupply, the same capacity handles ammunition, water, or spare parts, delivering essentials in hours, not days. With modular interiors, the platform can swap from troop transport to casualty evacuation, or sensor-laden ISR patrols, all without needing a runway or a ship's flight deck. This is where numbers meet mission. The payload is not just a headline, it is the foundation for real-world operational scenarios the Marines face every day. March 6, 2025 brought the first full-scale hull test in Narragansett Bay, an early step that confirmed basic buoyancy and safety systems with a crew on board. REGENT's production team, working out of a 255,000 square foot facility in Rhode Island, has since ramped up manufacturing lines to support the next phase. The Marine Corps Warfighting Lab continues to monitor progress, with a program update on March 11, 2026, citing steady advances in medical evacuation, interior design, and electric motor reliability. Sea trials have shown the Viceroy can operate in wave heights up to 4 feet, but anything rougher still poses a challenge. Certification hurdles remain, especially as the Coast Guard reviews the design basis agreement for this new class of vehicle. REGENT now targets initial low-rate deliveries to the Marines in 2027, but full operational acceptance will depend on how the vehicle performs in broader test and evaluation. Open questions about survivability, long-term durability, and mission integration are still on the table, even as the program moves from prototype to production. Today, the Viceroy stands as a real $7 million prototype, tested on water, proven on foils, with a payload of 3,500 pounds. Yet combat certification, integration, and doctrine remain open questions. For the Marines, the promise is tangible, but the verdict is still in the making. What is your take?